So the single slit, they refer to it as being diffraction rather than interference is what we usually call the double. But it's going to look a lot alike. But what we're going to have is just one slit. And then we're going to have the screen over here. Okay. And so slit in the screen. Now, what they'll do is they are going to talk about the fact that this slit has some width. And that width will be A. Other people call it W for width. No, the order numbers are always positive, and so when you talk about first orders, then it's, you know, one on each side kind of thing. So there's no implication for whether it's above or below the central max. When they talk about this language of first order minimum, second order minimum, there's no distinction.
I think I was referring to like minus lambda by 2 and positive lambda by 2.
Yeah. So, but the positives are usually above and the negatives are usually below with the way they set it up.
Okay, thank you.
So this is the positive y direction and this is the negative. So yeah, they might do it that way, but the naming for like the purple and the blue names, those don't indicate negatives at all.
Okay,
the orders will, and like you said, the half lambdas will, and things like that. So the y values will, but the others, the names, no. So, and we're gonna still have that this distance from the center of this slit over to here, this is going to be r, just like we had before. Okay. And then when we go up to some point along the screen, then the distance from that point to the center here is going to be our y. And we'll have some angle theta. Once again, making our nice right triangle that we had previously, just like here. So we'll get that same geometry. As, you know, tangent of theta is y over r. And if we invert that, then what we get is that y is r times the tangent of theta, like so. And so what happens is that if we illuminate the slit with our light source, then the light is going to spread out from this slit. And this process is called diffraction. Okay. So, I mean, if the wavelengths are small compared to the size of the opening, then it goes straight through and there's not hardly any diffraction at all. But once the wavelengths become on the order of the size of the opening, then it's going to spread out into this kind of like, you know, shadow region things. You know, so like if you like take a laser beam and send it through an open doorway, there's no diffraction in that case. But when you make that doorway the size on the order of the wavelength of the laser light, then you get a lot of diffraction. You get a lot of, you know, bending out into this kind of shadow region. You know, because if there is no diffraction, then the pattern is going to be a, you know, a width of A on the screen, right? That's all it's going to be. But once the openings on the order of the wavelength, then we get this interesting feature coming out. And what we're seeing is it's going to be, you know, diffraction. And we're going to plot the intensity again versus position along the screen. And as a general rule, they'll make the positive y go up and the negative y go down like this. And the pattern is very different for a single slit. Okay. you get one big central maximum, and then it goes to a minimum. And then another maximum, and then another minimum. And it goes something like so. Pretend it looks better than it does. So this is our central maximum. And then this is our, first order maximum. This is the first order maximum on the other side. Okay. And then what we'll get are the minima. First order minimum here. First order minimum there. Second order minimum here. And second order minimum there. Okay. Now, one of the things that's interesting is that essentially the easy formulas that we can write down and work with are only for the minimum. So we do not have a nice formula for locating the maxima in a single slit setup. Okay, so that's one of the big things, is that what we can get are only the maximum. No, only the minimum. What am I doing? So, we haven't picked out the right color for the minimums. Only the dark spots, only the minima are the only formulas we get. So this is a distinction. Now, there's a funniness in the way that they calculate this. So to get the minimum, what they talk about is that the light from the upper half of the slit cancels the light from the lower half of the slit, pairwise. And so in some sense, that's kind of like using that the spacing is, half of A. Okay. And so if you look at the destructive here, you get these odd half wavelengths. But if they use that the spacing is more like A on 2, and then multiply by 2, then you cancel all the halves. Okay. And so the formula we end up with for this one is that it looks like our A sine theta is equal to m lambda. So when you do m times lambda, that looks like the constructive interference, but we're getting the darks. But that's because we ran like A on 2, and then you had like a lambda on 2, and then you canceled the 2. Okay, that's the best argument I got for not being able to redo the derivation. There's one more distinction. M's there's no 0. Because if we ran m equals 0 at the dead center, it would be dark. And at the dead center, it's bright. And in fact, that was actually one of the things, is that when can't remember which physicist had worked on this result, and they presented it, and I think it was, I can't remember, it was Poincaré, or Poisson pointed out, I think it was Poisson, that sounds right, pointed out that, well, your formula implies that, you know, oh, at the center, it's going to be bright. And I was like, surely it's not. And then they ran the experiment and surely it was. And so that was one of those funny things, I guess. So, and what they did was instead of illuminating an opening, they had like a solid object and illuminated the object, and you get the same kind of pattern. Okay. And it was not obvious that it would be bright at the center of the pattern when you had the light being blocked by an object like a coin or something like that. Okay. So yeah. But what this does mean is that our first order minimum, this is when m is +1. And the second, this is when m is +2. This one is when m is -1, and this one is when m is -2. So they line up again. So it's real pretty. 1 is the first order, 2 is the second order, -1 is the first order, -2 is the second order, and so on and so forth. But the formula looks like constructive, but it only gives you the darks. And that's because there was like an A on 2 that canceled the halves over here, and then this is how we end up there. Okay, so be careful with that. Same geometry though. But we can only find darks, we can only find minimas. On the double, we can find the minimas and the maximas, but the minimas have that offset. The m equals 0 is the first order, the m equals +1 is the second order. But the brights are good, the maxes are good. +1 is 1, +2 is 2. That's nice. The darks for the single are nice. Okay. And this leaves us with one more,